this is 8.4 lesson part 2. This was using the idea of factoring still where the A value is greater than 1. We're going to look at the other half of the Skills Practice 8.4 worksheet where we left off in our last lesson as it relates to solving. Now recall, we are looking for the two places where the x-axis crosses, the parabola crosses the x-axis. So we're having to factor this expression apart. And so I want you to keep that in mind, that that is the goal, that I need to break apart that squared term as we are working on that. We had our rules that we need to remember, our plus minus rules, and so forth moving forward. So looking at this one, I'm sure that last lesson was, maybe a little complicated because of this guy not being a 1. So remember from 8.3, I kept telling you that that top number really is A times C, so 2 times 3 is 6. And that middle number, that B value, always goes on the bottom. And we always want to ensure that we are in descending order, as you see that here. And as we get through the lesson, we'll see some examples like that. So again, I'm still looking for two numbers that I multiply together that give me 6, but add together to give me 7. The shortcut rule that I gave you in 8.3 says both of these have to be positive. So of course, my options are 3 and 2. 3 times 2 is 6, but 3 plus 2 is 5. Okay, so then I'm thinking, okay, well, your first thought might be it's not going to work, but don't forget, and sometimes students forget about that. In this case, 6 times 1, that 1 will be to our benefit as well. And so here our values are actually 6 and 1. Now, we do need to bring down that first term, and then we're going to fill in those middle two terms with those two numbers that we just found. And this brings us to where we, were at when we left off in lesson 3. Certainly the idea of finding the GCF, but then we also are going to solve. This shares the common 1. And so we can see the format of solving for this expression is the same, which is what we had in the last lesson. Now I'm going to bring the 0 down now, and then we can set them both up equal to 3. That 0 product property. And so the first one, x is equal to -3. Now, every once in a while, I get a student who they're rushing. They forget that, the 2's in front of the x means I'm dividing by 2. So in this case, the other x is -1/2. So don't make that mistake that you're overlooking which number we're actually dividing by. Let's try another one. So again, using my x here, look at the pattern. I know they're going to be opposite values. 3 times 2 is 6. That middle number goes on the bottom. Two numbers multiplied together that give me 6, but add together to give me -7. And I apologize. Hopefully somebody out there was saying, no, Mrs. Cascadden, that was supposed to be 2 negatives. Again, like in the last slide, we had the 6. 3 and 2 only give me a -5. And so we will use the same 6 and 1 that we did in the last lesson. Our signs are just a little different. So I'm going to bring down those two middle terms to make up for that -7n that's in there. I'm going to factor this out. So taking out the common 3 in this case, so n minus 2. Here they share a common 1. I have to get that sign to flip. Remember that idea. And so n minus 2. And then I also have 3n minus 1. Those I can set equal to 0 because we're looking for the two places where it crosses the x-axis. And then this one is going to be n is equal to 1/3. These are valid locations on the x-axis. I can map them, and so they are valid answers. Let's try another one. Now, we haven't done one of these yet where I pointed out this idea, but remember, we always look for the GCF, and this guy actually has a GCF. He actually has a 2 as a common factor throughout. Now I'm going to run this one 2 different ways, okay, just so that you see that it could be easier to take the GCF out first, sometimes not. But sometimes it is easier because the numbers get a little large, and if there's a GCF, then we can see that it doesn't matter if it's there. So I'm going to run this twice. So if I do that with this one here, I'm going to have a 3 on the top, 4 on the bottom. Hopefully you're thinking to yourself, factors to get 3 are going to be 3 and 1. So this is 3 and 1. They're both positive. So I'm going to bring down this first term. I'm going to ignore, since we're solving, I can ignore this guy. There's no variable on it. In another time, if we have a chance, we'll look at it if there is one. And so then we're going to use our factoring rules. Take out that 3h, h plus 1. I'm going to take out the common 1, h plus 1. And so we end up with n plus 1, 3h plus 1 is equal to 0. Now, before I go any further solving this one, I want to show you what would happen if I didn't take out the GCF. So now I'm working with the number 12 and the number 8. Now, these are low numbers, so for this one, that's okay. But when these numbers start to get a little bit larger, and you will see that in our work, sometimes if a GCF exists, it makes it a lot easier to find the factors than if they are much larger. So again, these are both going to be positive, okay? And then so 2 numbers that multiply together that give me 12 and add together to give me 6. 3 and 4 are going to give me a 7, but 6 and 2 will give me that. So I'm going to bring down, we were working with the original term, so I want to make sure that I start with the original first value and end with the original last value. And so if I factor out the common 6h, I get h plus 1. And if I factor out the common 2, positive 2, I get an h plus 1. Now, what's interesting here is I have h plus 1, which I have over here in the other one. The other one is 6h plus 2. Now, if you analyze these two, you'll see that this one has a GCF in it. There's still a common 2 in here, but I don't have it over in this term because I took it out earlier in the expression. And so this would not be considered final answer if we weren't solving but just factoring. But if I solve, n is equal to negative 1, or h, sorry, h is equal to negative 1/3. Here we have h is equal to negative 1. I'm going to set this one up to show you. 6h is equal to negative 2. Divide by 6 and reduce it. H is equal to negative 1/3. So I don't have to take it out, but it might make my work a little bit easier. If I were factoring it, if my final answer and it didn't have the equal 0 on it and I was factoring it, this would be my final answer. I would have to keep the 2 there, and this would be my final answer factored, not even this guy up here. So that is important to understand. So I'd like you to try number 21 and see what happens, and we'll come back. Hopefully you were thinking to yourself, wow, Mrs. Cascadden, this one's a fill here. But again, we're missing the 0, and if you recall back from our last lesson, we needed to recreate that 0. So we need to subtract that over to the other side. Now, in some of our other examples, we only had 2 terms on the left-hand side and no 0 on the right-hand side with 1 term. We moved it over, but we do have 3 terms on the left-hand side, so we have to collect those things that are alike. So I have 9y squared plus, so 18 minus 6 is 12y minus 12 equals 0. Now, here's a good example of when I would want to take the GCF out first. 9 times 12. So we're talking over 100, you know, that I would have to find. So 108 would be the value for which I have to find factors. Well, that's not an easy thing to necessarily do. So I'm going to take out the common 3 that they share. And we'll see how that's going to be just a little bit easier to solve for than it would have been had I stuck with the original value. So this now becomes my my x values here. So my first times my last gives me a negative 12. My middle is a 4. So two terms that multiply together. I know they're opposites because of the pattern of the signs. So two numbers multiplied together that give me negative 12, but add together to give me 4. Wow, that was a lot easier than me trying to find two numbers multiplied together that give me negative 108, but add together to give me 12. So right there is a prime example of why, if I can, taking out the GCF is important. So I have something that's a little bit easier to work with. So 3y squared plus 6y minus 2y minus 4, okay, we're going to factor that, and so we're going to take out the 3y, so I have y plus 2, I take out a negative 2 to get the y plus 2, so I have y plus 2 times the quantity 3y minus 2, we set that equal to 0, so we know one of them is y is equal to negative 2, so my 3y minus 2 equals 0, so 3y equals 2, so y is equal to 2/3. Valid answer. Let's try one more. So terms on each side, we need to simplify this to have 0 by itself, so I'm going to subtract over the 8b, I'm going to add over the 12. So these two come together. I have 10b squared. I have minus 23b plus 12. Well, guess what? There is no GCF on this guy here. If I use my diamond, I see that I get 120, okay? And I have a negative 23. So you should be really thinking long and hard about what some of those factors are going to be. And I want you to pause this video and take a moment to really think that through. All right, so if you're thinking about factors of 120, maybe 12 and 10, okay, come to mind. We have 60 and 2 are there. We have 40 times 3. We would have 30 times 4. But none of those right now are going to, are making that dent that we need in terms of getting a 23. So we now need to think about other factors. Well, some other factors of 60 and 30 happen to be 15. And they happen to be 15 times 8. Now, if we look at the pattern, they're both going to be negative. So we have a 15 and an 8. 15 and 8 give me 23. So if I set this guy up, 10b squared minus 15b, and you have to be persistent sometimes. And actually, if you look at this, the original problem, they already had the factors there. Okay, this actually turns out, the FOIL line. Okay, you can see that in this next line here. But that might not always be the case. That just had to be a unique scenario. So we're going to take out a 5b, which leaves me with 2b minus 3. I really need a 2b minus 3 over here. They share a common 4. So 2b minus 3. So we have 2b minus 3 times the quantity 5b minus 4, which equals 0. So 2b minus 3 equals 0 gives me b is equal to 3/2. 5b minus 4 gives me b is equal to 4/5. This is valid. All right, so your homework is to complete the bottom half of 8-4, 16 through 24. Please work through and have the tenacity to find some of these factors. You'll find some of them will get a little larger. Don't forget to focus to see whether or not there is that GCF first. Good luck.